Okay, so I had a few students that asked me to create a video that gave some more kind of walkthroughs in regards to balancing equations. So I wanted to show you the same process, but I also wanted to give you some visual guidelines to help you see it better in regards to how we are doing this. Okay, so what I've done is we have our equation, and then I have colored dots that represent each specific element. So as we go through this, I'm going to be writing it down here and balancing it like we normally do, and then I'll be doing our dots. So we have H2 plus N2 yields NH3. Okay, now I'm going to go ahead and I'm going to pull over my dots. H2 is 2 red dots, N2 is 2 green dots. And then NH3 is a red or a green with 3 reds. Okay. So when I balance, I do the same process. So I have my H and my N, H and N, and I'm going to count. I have 2 on the left for each. I have 3 hydrogens and 1 nitrogen. Okay, so now I can start choosing an element. Now, because I like nice even numbers, I'm going to choose the one that has 2 and 1. So I'm going to start with the nitrogen. Now, down at the bottom, in order for me to balance my nitrogen, I need a coefficient of 2, which changes my nitrogen to 2, changes my hydrogen to 6. Now, our visual representation of that shows now I have 2 of my entire little green and red dots. Okay. Now for my hydrogen, I have 2 on the left and 6 on the right. So we know we need to have this be 6. And in order to do that, I need to multiply by 3. So to show how that works, I need to bring in more dots, so I have 6 total. Okay, now I know that my numbers match, but I can go in and I can say I have 1, 2, 3, 4, 5, 6 on the left of my hydrogen. I have 1, 2, 3, 4, 5, 6 on the right of my nitrogen. So my hydrogens are balanced. On the nitrogen, I have 1, 2 on the left, 1, 2 on the right. So nitrogens are balanced, which means that my correct balanced equation would look like that. Okay, now, you don't have to do the dots, but it is something that if it helps, use a colored pencil or use markers to kind of help you with that visual representation. Okay, let's go to our next one. We have potassium plus magnesium bromide yields potassium bromide plus magnesium. So I'm going to drag my dots over. I have potassium. I have 1 magnesium and 2 bromines. I have 1 potassium and 1 bromine. And then I have 1 magnesium. Okay, so I have my little dots. I'm going to write it out again. So K plus MgBr2 yields KBr plus Mg. Okay, we're going to draw our line and let's count our atoms. So we have K, Mg, and Br. Okay, so on the left we have 1 potassium, 1 magnesium, 2 bromines. On the right we have 1 of everything. Okay, now let's go ahead and we're going to start our balancing. So the only thing that's different currently is our bromine. If we have 2 on the left, we need 2 on the right. So in order to make that be a 2, I add a coefficient of 2. That also distributes to my potassium. So visually, the way that this works is if I need another bromide, I have to add an entirely new potassium bromide in order just to get a bromine. Okay, so now I have 2 potassiums on the right. I need to have 2 on the left, so I have a coefficient of 2. Luckily, I don't have to add any magnesium or bromines because I already have it. It's by itself. So now we can just count. We have 1, 2, 1, 2. Potassium is good. Bromide, we have 1, 2, 1, 2. Bromine is good. Our magnesium, we have 1 and 1. Magnesium is good. So our overall balanced equation looks like that. Okay, so again, the little dots are just to help you see it visually as I'm doing the process. Okay, let's do one more with the dots, and then we'll do one without the dots. That is a little trickier. Okay, so for this one, we have CaCl2 plus K2S yields CaS plus KCl. Okay, CaCl, K and S. CaCl, K and S. Okay, so even though we have more elements, process works the same way. So I have Ca and 2 Cls. I have S in the middle and 2 Ks. I have 1 calcium and 1 sulfur, and then I have 1 potassium and 1 chlorine. Okay, so I'm going to do my counts. I have 1, 2, 2, 1. On the right, I have 1 of everything. Okay, so we are going to start with our chlorines. Okay, for our chlorines, we know this needs to be A2, so that changes to A2. And because we distribute, if we change that to a 2, that means we are putting a coefficient of 2 in front. That also changes our potassium to 2. Because we can't just add a chlorine, we have to add the whole potassium chloride. Okay, so now we can do our count again. We have 1, 2 chlorines on the left, 1, 2 on the right. So chlorine is good. Calcium, we have 1 on the left, 1 on the right. That is good. Sulfur, 1 on the left, 1 on the right. That is good. And then our potassium, we have 1, 2 on the left, 1, 2 on the right. That is good. So even though this looked like it's going to be a little more difficult because of all of the compounds, it was fairly easy. So this is our balanced equation. Okay, now I have one more, and this one definitely looks a lot harder and is a little bit more difficult because we have to go back and forth a couple of times. This one is not going to include the colorful dots because I will not have enough room if I do them. So we're going to do it the way that Miss J does it, just normally. Okay, so I'm going to draw my line. I have S, I have H, N, O. Now the reason we can't do this as NO3 is because over here it is NO2. So we can't balance all of the NO3 together because of that. So we have S, H, N, O. So on the left, our counts, we have 1, 1, 1, and 3. On the right, we have 1 sulfur, we have 4 hydrogens, we have 1 nitrogen, and then we have 7 oxygens. Okay, so we are going to start with our hydrogen. Okay, so on the right, we have 4, left, we have 1, so we know this needs to be a 4. Okay, now that also updates our nitrogen to a 4. and it updates our oxygen to 12. Okay, so our hydrogens are balanced. Let's look at our nitrogens. So our nitrogens, we need 4 over here. So we change that to 4. Our oxygens are now updated. So I have 4 oxygens right here. I now have 8, and I have 1. So 8, 9, 10, 11, 12, 13 oxygens on our right-hand side. Okay, so the only thing that is not balanced right now is our oxygens. Okay, now here is where it can be a little tricky. What we can do is we can say, okay, I'm just going to go 1 up in my oxygens. Okay, if I do that, okay, I have to change this whole thing. If I say that's a 5 now, that changes that to 5, that to 5, and I now have 15 oxygens. Okay, so if we do that on the right-hand side, I have, for nitrogen, I can do that as a 5. That changes my oxygens to, again, I have 4 plus 10 plus 1, so 15. Okay, my oxygens balance out, but my hydrogens don't. And I have a 5 on one side and 4 on the other. And my 4, I have 2 different places. So there is no way for me to get an odd number of hydrogens. So what I have to do is I am going to have to change this to a 6. Okay, because I know that I can't get an odd number of hydrogens because I have 2 and 2, so it's always going to equal an even number no matter what I do. Okay, so if I change that to 6, that's a 6, that's a 6, that turns into 18. Okay, so now I go back and I do the same thing. We'll start with our nitrogen, that to 6. That changes our oxygens. I have 12 with my nitrogen. I have 4, so 12, 13, 14, 15, 16, plus 1 with my H2O. That gives me 17 oxygens. Okay, now, if I change this H2, if I put a 2 here, that changes my S as well, which we don't want to do. We want to leave that S alone. So we have to change this one. So if I put a 2, if I put a 2 here, that gives me 4 hydrogens on there, and then the 2 with the H2SO4, that gives me my 6 hydrogens. My oxygens now change. I have added 1 more, so now I have 18 total. Okay, so everything matches now, which means we are balanced. So my overall balanced equation is going to be S plus 6HNO3 yields H2SO4 plus 6NO2 plus 2H2O. I hope that helps in regards to some balancing tips and tricks.